I don't think I've ever been so excited and yet so nervous for a project, because I finally picked up one of my holy grail machines. I've got an Amiga 4000. I got this from eBay a couple of weeks ago now, sold as spares and repairs, because the battery, it's done a number on this area, caused quite a bit of damage in and around the real-time clock and up towards the SIM slots. But equally, there seems to be a bit of damage up around here in the audio section, presumably caused by these old capacitors. So let's spin around to the desk behind me and take a closer look at what we're dealing with. Pull the microscope out to give you a better look at the damage, or should I say a better look at the carnage, because yeah, that's where the battery would have been, and it has absolutely wrecked this area. I would say all those traces there will have multiple breaks in them. Those vias just in below those resistors, they are most likely damaged as well. And one thing that slightly complicates this is that the A4000 is a 4-layer board and there are internal traces in this area. So I think the best thing we could do is try to strip everything around the affected area and just take our time and buzz everything out. The damage does seem to end up around here, beside that 245 and the trim cap. Notice we're missing the clock crystal. Those vias there will need a bit of inspection as well, a bit of cleanup, but that does seem to be the end of the damage. If we start moving up the board, everything up here all looks okay. Back down to this area though, and the damage has spread up the board just to beyond that gal. You can see that all looks rather questionable, and down around that bit of 7.4 series, that's all rather crusty looking. So I think we'll need to remove everything up to about that point. Over on the SIM slots, you can see those traces in between them there are quite crusty as well. So I think we'll just pull those first two slots anyway. Might need to pull the third one because things just in there look a bit damaged. There certainly seems to be evidence of corrosion in there, so might just be worthwhile removing all of them actually. They do still all have the little tabs for keeping the memory modules in place. They are all just plastic tabs on this, and I know that they do like to break off, but it is all complete on this board. Things are quite crusty up here as well, aren't they? So yeah, those first couple of SIM slots anyway, we'll remove them to start with. Or well, should I say bank 2 and bank 3. Just take a quick look at the bottom side, because it hasn't got away with it either. That is the underside of the real-time clock chip, and you can see corrosion that has worked its way through those vias there. Does get quite bad down towards the edge of the board there. That's obviously where the battery would have been. That's the pins for it on the bottom side. And again, working over towards the SIM slots, yeah, things are kind of green. Up and around that audio section then, there is obvious signs of damage as well. Presumably this though was all caused by leaking capacitors, and in fact that cap, that looks as if that has exploded on the board. You can't see it really from this angle on the microscope, but I can get a leg of my tweezers there in underneath the can. It is definitely lifted up on this positive side there. I think that cap has previously went bang. So again, I think we'll just need to strip this entire area, buzz everything out and make good. Hasn't spread just as far here though. It is just really limited to that direct area there. We don't need to move too far up the board before things start looking relatively clean. Whole board will be getting a recap anyway. So yeah, I think all we can do is crack on and start removing things. We'll just start in this area, and as per always, plenty of flux first of all. and we're going to try and flow a lot of clean solder into these joints. The corrosion is quite excessive though, so I have no idea if I'm even going to be able to get any clean solder mixed into these joints. But it does seem to be taken there, and if we can get a bit of clean solder in here, that will just aid in getting these components off. Okay, that's all the surface mount stuff reflowed in this area anyway. So I'm just going to put a bit of capping tape over the edge of the SIM slots there, and then we'll try hitting all this with hot air and see if we can get that surface mount stuff off. So I've got this set to 400. Let's just see how we get on. Okay, that all came off relatively easily. Do need to remove the through-hole bits there. I'll do that in a second. All the positives that we've removed there, I'm just going to replace. I don't think they'd ever clean up, to be honest with you, just because of the amount of corrosion on them. The GAL though, and the bits of logic, and those couple of diodes, I think I will just try to reuse those. So I need to remove the clock chip, that resistor pack. There's a pin header here that I need to remove, but I'm also going to pull all those positives as well, just because it's all a bit crusty, and I was going to remove that trim cap as well, wasn't I, from the other side. Just while we're waiting for the MU gun to heat up to remove the through-hole bits, we'll go ahead and remove these surface mount resistors on the bottom side here. I'm not going to remove any more than that on the bottom side in terms of the surface mount bits. The rest of it all looks okay. There's a little bit of crustiness on some of the vias there, but I reckon we can try to reflow them or try to patch them without having to remove those components. The components themselves all look fine. Although, saying that, I think I'll just remove those 3 caps because the corrosion around them is quite heavy. Right, this thing is up to temperature. Let's see how it gets on. Yeah, I'm not actually sure if any of that has come free. That's pretty well stuck there still, as is that. Trim pop might be loose. Yeah, got that off okay. Real-time clock chip though. No, it's still well and truly down there. So all we can do is go back to the other side again, try and get a bit more clean solder into these joints and just try it again. This is why I've definitely grown to prefer working with surface mount, because it's just easier to remove things, easier to fit things as well. Through-hole parts may seem easier, because you know you've got a leg going through a board, something substantial to work with, but in terms of trying to remove through-hole parts, especially on a 4-layer board, yeah, it's just it's not the easiest thing. What we'll maybe do actually is just try and use the soldering iron in conjunction with the MU gun, just to try and get as much heat as we can into those legs, to try and make sure the solder all gets extracted. Okay, hopefully it all comes off now. Resistor pack still putting up a fight on one pin there, just that one. But that's it out now. Real-time clock chip is coming too. Come on. There we are. And what about this pin header now? Nope, that is still stuck tight. My problem with this is that it fell through the board slightly as I was reflowing it earlier. What I may need to do with this thing is resolder all that and just go at it with the hot air. Nope, I cannot get that at all. Right, drastic measures. It's just a standard pin header. I have any amount of them. So what we'll do is we'll just cut the pins off. I'm just covering that each time I snap one of them off so it doesn't go flying. You know, it'll just bounce off my hand. But we'll cut those pins off and then we'll try and get the plastic off. And then I'll just remove each one of them individually by hand. Right, hopefully now the Moo gun can clear the rest of it. Almost. And there we are. Big blob of solder there. And where was that other hole that I blocked on the resistor pack? There, that's better. Next job I think will be to remove the SIM slots. I think we'll just remove those bottom two. Although I might remove that third one as well. We need to get those off. Just going to be the same method though. And you don't necessarily need to watch me desoldering, what, 72, 144, 200 and something pins. We'll come back once I have that done. It might seem a bit drastic, but the corrosion is so heavy on the solder mask that my fiberglass pen just will not touch it. Even this thing, with its rubber tip, is struggling in this sort of area here, just where things are particularly bad. It has brought up most of it okay, and the rubber tip is safe to use. It's not going to damage the copper, or well, shouldn't anyway. But I'm just going to continue working at it here, including this area just around SIM banks 2 and 3. You can see that I went ahead and removed all 5 of the SIM slots. There they are, and it was definitely worthwhile removing them. As you can see, the bottom of that one, for example, is quite green. I do have replacements for them, 5 replacements. They are the type with the metal clips on them, so they will be better in the long run. But more on that later. For now, I need to get back to this and continue trying to clean this up. Once we've got all the copper exposed, we'll bring a microscope in and take a closer look at things. Carnage doesn't really cover it. We have broken traces everywhere. A couple of missing pads as well. 4 of them there. 1, 2, 3 and 4. But that's easily enough fixed. Those traces are just completely gone, aren't they? That will need to be completely replaced. That trace is wrecked as well. Those 4 vias, they'll need to be repaired, and traces going to those pods will need to be replaced. Same down here. Traces that presumably, ran up here, connecting there, and running up there to connect there. Just absolute toast. Horrible. Don't know if I can maybe try and clean some of that up a little bit further. Yeah, I don't actually think there's anything there underneath that. There's maybe a little bit of copper. Wonder if I maybe got it with a knife. But yeah, I think it's a bit of a lost cause, isn't it? Because the trace is going to be wrecked underneath it. Yeah, there's just nothing there. It's just a shadow of what used to be a trace. Right, next job I think is going to be flow a lot of solder over this. So we will flood everything in flux. We'll drag a lot of solder over just to tin everything. That just further helps show us where the breaks are. And there's another break there. Luckily, when we start going this way on the board, that's up towards that gall. It was rather crusty looking, but everything there looks okay. Coming back down towards the SIM slots, everything up the board here looks okay. That all looks okay. Although there's maybe just one there. Might need a bit of investigation. Down onto the SIM slots themselves. Definitely a broken trace there. That third one along, maybe once just checked, as do a couple of those other ones. But it's not too bad. That's interesting, isn't it? Most of the corners on this are all like sharp 45 degrees. There's a nice sweeping corner. Sweeping bends on that trace. Wonder why they did that. And look at the way the trace is thicker there. Gets thinner coming between those two holes. And then goes thicker again and then thin again as it comes down there. There's another one of those bendy traces. Bit of damage down around here. I would say that looks like it's broken there and there, possibly broken there as well. Possibly a crack there. That's definitely broken there, yeah. Bit of patchwork to do around that component. Yeah, let's drag a lot of solder over all this. And then we'll start thinking about making good. I know it blocked a lot of holes there, but I'm not worried about it because we're now going to go over the whole thing again with some wick. I'll just mop up the excess and hopefully unblock any of those holes. Also help us pick up any wee bits that we missed. Okay, so let's run a few patch wires. I'm going to be using PCB Explorer as a reference for where the traces are meant to go. And I think the best way to approach this would be just to try and work across the board. I'm going to need to test everything as we go because there are multiple issues. Now, to repair the traces, I'm just going to use the usual solid core black Kynar wire. And I won't bore you doing all of it on camera, but the idea is that, say for example, where we have a broken via. Now I know I said I'll work left to right, but let's just concentrate on these three, just because I think they'll be easy to show you on camera. So we can select them in PCB Explorer. You can see that we should have three traces coming down here to those three vias. They then go to the bottom side of the board with a read-write signal going to the fast RAM, and then the other two are just LEDs which come down to this component U311, which is 7407. Now there are breaks in and around those traces down here, but rather than have patch wires looping across the board, what I'm going to do is we'll take a bit of the wire, we'll strip quite a bit of it. I'm going to put that down through the via, and then on the top side here, let's try and route it along the board, roughly in the line of what the trace would have been. Just going to put a bit of black tape just over that wire, just to hold it down for me, and we'll get a bit of flux, and then with a bit of solder on the iron, let's try and get this attached. Okay, I think I got it there. We'll then just cut off the wire using a knife. And let's just check continuity then on the top side for that trace. So with multimeter, from our new bit of wire, that trace runs along to that via, and that is correct. Where does that actually wind up though on the board? Goes away over to the other side that you can't see at the minute, to a pin on U904, and that is now making continuity right through the board. So we need to go to the bottom side now. So we should now be able to go from there across to there, and yeah, That is one trace right through this board, completely fixed. I just have a million others to do. I suppose since we did that one, I'm just going to do these two beside it. So there's a problem that we need to be aware of. I have made that wire on there, but you can see now that the actual trace has lifted off the board. It'll be okay once I get a lot of solder mask on it. And it's not like I'm running my iron particularly hot. I've only got my iron at 320. But it is something we're going to have to be mindful of. Definitely don't want to be causing any damage while trying to repair the damage. Okay, I think that's those two repaired as well. Not particularly happy about that solder work there, but let's just check continuity, then I might revisit that. Got the meter out again here. So the first one of those, which is the IDE LED, it runs from a via there across to that via, and yeah, that's fine. The other one then, which is just labelled as LED, power LED maybe, is from that via to that one, I think, and yeah, that is now okay as well. Let's just be sure we haven't shorted the two together anywhere, and no, we haven't. That's fine. Down around here though, there is other repair work required. That makes its way down here to connect to that point, but as you can see, it doesn't. Trace comes down there. That's okay, but it's just at the connection to the pod. It's broken. Then it actually loops back to this other pod, and the connection between those two is broken as well. So there's a break in it just there. And in fact, that little trace that connects those two pods, it must be broken just at that pod as well. So that's a problem. What about that other LED trace? Comes down to that point. That's okay. Lifts back to there. And that's not okay. So there must be a break there again, is there? Yeah, there must be a break just at that connection there. So yeah, I'll get on and do what we can here. I'd usually say I'll be back in a minute. Yeah, give me a couple of hours. I've repaired everything from this point across the SIM slots. Quite a few broken joints, 21 in total, I think. And I've also tried to repair around that surface mount component, the SN7407. To be honest with you, I'm not sure how well that is going to hold up when we go to fit the component. But if we look at it there under magnification, you can see that there are patched traces everywhere, and there is a chance that when I go to fit the component, if I even can fit it, because obviously these points here are all raised up now because of the wire on it. But when we go to fit the component, those wires might come loose again. But to give us the best chance of doing it, I know I said I was going to try and reuse the logic. I've decided instead just to replace it all. It's not expensive, and I think it would be better to do that rather than risk fitting a component that is potentially faulty and then having to try and remove it again. Because if that was the case, it most definitely would lift all the patch wires when removing it. So we've done everything we can on this side of the board. You can see some of those patch wires there that I had to run to make good those traces. If we come back over this side, we have another problem to deal with. These vias, they are completely rotted out. And in particular, those four there, they are underneath the chip that has to be sat here. In fact, there's maybe another one there. I'm not actually sure where that pod connects. I'll have to pull up PCB Explorer again. I almost managed to get that via cleared, but there's just too much corrosion, too much gunk in most of these that I cannot get the wire down through it. Doesn't matter how much heat or how much flux I put into it, I cannot get these cleared. So I'm going to try something that I have never done before. Yes, we could just run patch wires from the top side, loop them over the side of the board there and make it off to the bottom, but that will be very unneat. Rather, I'm going to try and drill these out. So I picked up a hand drill set. This set goes down to 0.5 millimeter, but Also picked up this little set which goes down to 0.3mm. I think we will just start with that, the 0.3mm. Right, I'll have to use my phone as a torch because it's too dark otherwise. But you can see one of the vias there that we need to try and go down through. And you can actually more clearly now see the state of this board and what we're dealing with here. I'll come and get down through this one. The little drill bits are quite flexible, obviously just because they are so thin, so I really don't want to push on it too hard. Come on. I think we must nearly be there. You can actually see it has started to eat up the through-hole plating as well. You know what? I maybe wasn't on that via properly. And the one thing that we need to be really careful of here is that this is a multi-layer board. As I said, there are internal 5V and ground planes. So when drilling a hole, the last thing that we want to do here is cause a short between ground and VCC. There, we're through. What an absolute mess. You can see part of the copper plating there has came away as well. See if we can clean it up with a bit of IPA. And yeah, we're through it. I mean, yeah, I can still see some of the plating through the hole. I think that's a ground. Let's just check with the meter. I can go to one of the grounds here, for example. And yeah, that is. And it's still making a connection. So that seemed to work okay for that one. Should we try going down through this one as well? See if I can get lined up to it slightly better this time. These drill bits are so small that they don't really have a pointed tip on them. They're just like a flat tip. So getting them started is kind of tricky. There we go. Look at that crustiness coming out of that. That is horrific. Maybe got through the board a little easier that time. Let's just drop a bit of IPA on it. And again, that doesn't look too bad. So that's what I'm going to try and do for all these vias. Once we have a hole like that, I can then take a bit of a wire, such like that, and just stick it down through there. I can then make it off to the pod on this side, make it off the trace on the other side, and it should be good as new. Or well, it should work. I think it would be a stretch to say it would be as good as new. Look at the state of this board. So yeah, I have an awful lot of these to do, but I am hopeful that this will work. Well, it's now more patch wires than Amiga, but I think that is everything on the top side here repaired. We just take a look under magnification. Well, you can see what I mean. There are wires running everywhere. They are going to make it quite difficult to fit the new components, fitting those new surface mount ICs there. Still not really decided how I'm going to do that, because, you know, obviously they are looking to fit to a flat board. This is all raised up now because of the wires that I have running everywhere. I've got a couple of ideas, but before we jump into doing that, the first thing I want to do is try to protect everything that we've done here. I'm going to be using the solder mask for that. That will hopefully stop any shorts from occurring, but I hope that this stuff will also go some way to hold the wires that we have there in place, so that when we are trying to fit the new components, when we are flowing solder onto them, you know, that heat is not going to travel up say, that wire and detach it from that trace there where I've made the joint. So solder mask time. I just put this on with the tip of my tweezers. And yeah, it's not the prettiest looking when we do it like that, but I think we are beyond aesthetics when it comes to this machine. I'll be honest and say I am starting to wonder if this was a colossal waste of money, just because how bad the corrosion is. I'm not sure at this point if this will ever work again. I've tried to patch everything. I have tested everything, but undoubtedly, I'm sure I have missed something. And it's just the top side that we've been working on here so far. I haven't even begun to look at the bottom side or the rest of the top side. Yeah, there's damage up here and around the audio section, but I've also noticed that the corrosion is prevalent here, just in behind the joystick and mouse ports. There's a lot of vias and traces there that are heavily corroded as well. But one thing at a time, let's do this first. The new solder mask is now dry. I did put it on a bit thick in some places, but hopefully that'll just hold all those wires in place to allow us to fit the new components. So we'll start over here with the 7404. Now the silk screen markings might be gone, but looking at it as we are here, pin 1 is to the left. So this needs to go on like that. Problem though is that because of the wires in there, as I said earlier, our component is now rocking about a bit. I can't get it to sit flat to the board. So what I'm going to try and do is take a little bit of hot glue. We'll just cut a slither off this. I think that will be too much. Just let me cut a fraction of that then. We'll stick that little bit under the chip. Then I'm going to heat it with hot air just at 100 degrees just to melt that, and then we'll set the chip on top, push it into position. My hope is that the hot glue will just help hold this chip in its position slightly off the board. Turn the airspeed way down or our glue will just get blown all over the place. That's it going molten there now. Doesn't take long. And so we'll set the IC on here where we want it. And just push it down onto the board. That'll just set it into that glue. Then what I'm going to try and do is we'll just hold it. We'll go along with the tweezers and just push on the legs of it and get them down onto the PCB, because obviously we didn't fit wires to all of those pads. So some of them are sitting a bit lower than others. I think that's that side. Just before I do the other side, I'm going to try and solder this up. So a little bit of flux. And we're going to have to try and do this just one pin at a time. I would normally fit these, just anchor one pin and then drag solder. I don't think we're going to have the option of doing that here, just because of all the wires. I don't want any of them coming loose. I have a couple of bridges there, but hopefully I can just dab in and out a couple of times and that should solve it. This tip on the iron isn't really suitable for, soldering these pins individually. This would be more for drag soldering. But I think we got it there. So I'll do the other side and then we'll maybe just test it quickly. Okay, I think that worked. So let's just test it here with the meter. Now, being a bit of 7/4 series logic, the pin on the end from pin 1 down, that will be ground. And yep, that's right. And then the last pin on it, that will be VCC or 5 volt. Test that across to there. And yep, that's right. Now pin 2 there should be shorted to pin 4. Yep, that's correct. Goes to a via, then runs to a component on the bottom side. I'll test that in a second. Pin 3 should short to pin 1, and it does. Which in turn, that's one of the ones we repaired. Actually, it runs to that one there, but we can't get to it because it's now covered in the solder mask. But it makes its way right across the board to this pin on the IDE header. And yeah, that's fine. That's the IDE LED. 5th pin along is another ground. Yeah, that's alright. Then the 6th pin, that's actually not used, so don't need to worry about that one. Pin 8 is equally not used. Pin 9 is a ground. That's okay. Pin 10, well, it will be shorted to pin 12. And yep, that's right. And again, that makes its way to a component on the bottom side, so we'll test that one in a minute. So pin 11 is the power LED. That is connected to pin 13. And then equally makes its way across the board to a couple of positions up here, but the handiest place to measure it will be on U304 on that pin. And yeah, that is okay. So I think that has worked. Just let me quickly test those couple of signals that go to the bottom side. So pin 2 connects through the bottom side, okay, that's fine. And then pin 10, that connects to the bottom side as well. No issues there then. I think this is going to work. Just be the same thing for fitting the other ICs in this location. That's where all the patchwork is. So let's get on and get it done. So there's the problem that I was worried about. It just happened. That wire moved. In fact, it stood up straight in the air. So that is a problem. The solder mask just isn't strong enough to hold it. And that wire is now detached from the trace. So all we can do here really is expose that trace again. Try and bend that wire over and make it back off onto it. There, I think I got it. So let's test around this IC. Pin 1 goes to the bottom side of the board. Test that one in a minute. Pin 2 runs up here. That's okay. Pin 3 actually goes across to one of the ROMs. Actually goes across to both ROMs, in fact. On the 6th pin down, 1, 2, 3, 4, 5, 6. And no, that's not making connection. So it may well be the case that that patch wire which I fitted has come loose under the IC. Or in fact, you know what? I'm being stupid because I haven't connected any of the wires on the bottom side yet. Yeah. We're a bit premature testing things. I think I'll just go ahead and fit everything else and then we'll just test it all. Well, all new components fitted in this area. Need to fit SIM slots next. But before I do that, I need to say a thank you. Because when Kavanos heard that I had bought this board, he very, very kindly sent us a few goodies. 2 full sets of the SIM slots, and I think for our board here we'll maybe use the white ones because I'd rather keep the black ones for something else that's in here. So we've got those. We've got the daughter card, but this is an updated version of it because this has an ATX power connector on it. We can power the 4000 board using this rather than having to muck about trying to make an adapter cable plug into the original power socket. This does have to be plugged into it though for the power good signal. That needs to be routed to this card. But that's not the only stuff that he sent. In here we've got a replacement real-time clock chip, as apparently they like to feel, although we don't actually need it to test the machine. we have an absolutely awesome bit of kit in here. This is a BFG 9060, but a very special version of it. You might call it the debugging version that Gavanos produced himself. That's because this sits off to the side of the 4000. So let me move this. Normally the card plugs into the CPU slot like that. This version of the card plugs in like that, giving us access to all these chips here to help debugging any problems. Now I do actually have another CPU card for this board. Tell you about that in a minute. But the other thing that Gavanos sent is in here. It is a full replacement motherboard. So ultimately, I think that's what we'll do. We'll probably build up this board using the components from this one. But in the first instance, I did promise the guy that I bought this from that I would have a go at repairing it. And that's what we've been doing. And in fact, chatting to the guy I bought this from, he is a fan of the channel. He does watch the channel. And that's where the other CPU card comes in, because he very kindly included this A3640, although this is faulty. You can see it has a couple of patch wires on it. It's been recapped using ceramics. We'll not talk about that now, but this will be the subject of a future video. First thing I need to do though is try and get this one working. Just while we are saying thank yous, I want to say another one to Sparks UK, who very kindly sent me one of the power connectors for in there, should I wish to make up my own, say, ATX cable adapter. That was my original intention, and then Gavanos sent us this thing, which we can just power directly, so I think that's probably the route we will go down. But that's enough waffling for now, so let's continue assembling this, and as I said, I'm going to go for the white connectors on this one. 5 new SIM slots and everything buzzes out correctly. Now you might notice a couple of extra patch wires here, and in fact there is an extra one on the bottom just here. Must have missed a few bits while doing the repair, but I'm fairly confident now that everything here is connected to what it needs to be. There is, however, a problem, because while buzzing all that out, I did check between VCC and ground, and unfortunately we have a dead short. Let us take that on one of our logic ICs. Well, okay, not a dead short, but you know, 5 odd ohms. More or less a dead short. Now the board still does have to be recapped, so I suppose it is possible that one of these capacitors has shorted, you know, partly shorted, and that's what's causing the problem. There is damage in this area still to sort out, although I'm hoping all this will need down here is a reflow and a bit of a tidy up. So I think we'll just push on. We'll recap the rest of the board, and I'll try and tidy up this area here, and hopefully that short just disappears. Well, all the caps are off. I've reflowed that area. Haven't checked it for any breaks yet, but certainly looking at it, it seems to be okay. But that short, or that 5 ohms between VCC and ground, well, it hasn't gone away, I'm afraid. It's still very much there, 5.6, and that just does not seem right to me. Removed the 2 ROMs, removed that chip, and removed Buster, but it doesn't go away. So to my mind, there is something still partly shorted on this board. So to try and find this potential short, we're going to use the bench power supply, and we're going to inject some voltage into the 5-volt rail. We're not going to be putting 5 volt at 1.5 amps into it though. We're just going to go for 1 volt and 1/2 amp. We'll start with that. To try and find it, well, I'm going to use my phone with this thing. This was very kindly donated to me a while back actually, although I haven't had a chance to use it yet. Lee from YouTube channel More Fun Making It gave this to me. This is a thermal camera. He had it spare, and so he passed it on. As you can see, it gives us a thermal image of the board. Granted, you can't really see very much at the minute. There's my hand under it though. And the thinking is, when we power this up, if anything is getting hot, well, it should show up on this. It should light up as it gets hot. Now, notice there that at 1 volt, it's quite happily drawing 0.3 of an amp. So this thing is not current limiting at that. But let's just give it a minute and let's see if there's anything we can see here. This side of the board down here all looks to be quite warm. Although I will be honest and say I was resting my hand on it, which is going to heat it up naturally. So I don't think that's anything to worry about. Going over to this side of the board, we can see a few hot spots there, potentially. Although I think what we're maybe seeing is just reflection of the likes of the metalwork there. Not actually sure those are hot components. The whole board seems to be sitting just at about 22 degrees. What about on the bottom side? There's a load of ceramics on the bottom here, and a lot of them will be decoupling between 5 volt and ground. So I'm hopeful this is where we'll find the problem. But there isn't anything really jumping out, is there? Is that something there perhaps? C130? See the way it looks brighter than everything else? I think what we can maybe do is try to take this up a bit. Let's take it up to 2 volts, but we'll leave it at 1/2 amp. So I put on, you can see this time it is current limiting. It's limiting it to the 1/2 amp and 1.28 volts. So let's just go over the top side of the board again. You can now actually see some heat coming into the customs Alice there. You see a little bit of heat just going into the die on that. What about on the bottom side again? In particular at that cap we were looking at earlier. Yeah, it is now standing out, isn't it? It's sitting there at about 26 degrees compared to the rest of the board at 23, which is sort of the ambient temperature. Yeah, it's really hot in here. There's another one there actually. That is sitting quite a bit hotter than the rest. So potentially a couple of suspects there. Another one here as well, which is C305. Now they're not so hot that I think you'll be able to feel any temperature difference. No, see the whole thing still just feels cool to touch. But certainly we have a couple of suspects there. I think I'll start by removing that one. That's the one that we've seen light up first at 1 volt, 1/2 amp, and it's certainly lighting up there at, well, 1.3 volts. It won't quite get to the 2 volts. Let's use a bit of hot air for this. I suppose I probably should have looked this up on PCB Explorer to see what this cap is doing, but it's probably decoupling of some shape, form or another. Okay, let's see if that has made any difference to what we were getting on the meter. So between ground and VCC, that's looking a bit more sensible now. We are at 29 ohms rather than 6. Let's just try and read this thing directly. See if it is shorted. And yeah, it is. Although it's reading 37.6 ohms across it. I wonder if we should maybe try and pull those other two that were lighting up. C305 was one of them. And the other one, I think, it was up here, wasn't it? I think it was this one, C213. Let's just see if that does anything to our reading. And that's more what I would expect. We're up now at about 140 ohms. Yeah, that is what we would have expected. What do those two caps read, just out of interest? That one is shorted, just 10 ohms across that. And this one, yeah, that's shorted as well, just 9 ohms across that. That seems weird to me, having 3 of them gone like that. But let's see if we can figure out what they are now. I'd bet they're most likely just 100 nanofarad, or is PCB Explorer. So C130 is the first one we removed, yeah, 100 nanofarad. Next one we removed was C305, also 100 nanofarad. And then the last one we removed was C213, and yeah, 100 nanofarad. Okay, 3 new caps fitted. Let's just try it again with the meter. And yeah, about 150 ohms. I think that is more what we would expect. Okay, if we're going to test this, we're going to need a few things. Accelerator first, the BFG, and I have stuck my LC060 in here. As I was saying earlier, this is like a debugging version of the card, so it goes on the CPU slot in that orientation. I did spray a bit of our contact cleaner down in there. It was looking a bit crusty, so sprayed some of that in, give it a go over with the toothbrush. Has cleaned it up a bit, but potential weak area that we can always revisit. For this card, we do need to make one slight modification on the board, just with these jumpers here. They are the clock jumpers, and they're currently set for an external clock. The BFG though, as I understand, uses the internal clock, so both of those need to be changed to positions 1, 2, rather than 2, 3, as they currently are. We'll stick the daughter card in next, and along with this, I need to fit this wire for the power good signal from the board. That goes in there, and the power good signal itself, or the field signal as it's called here, that connects to that position. I've taken this old wiring loom here out of an old PC case. It'll give us the momentary power switch that we need, plus a hard drive LED and a power LED. Hard drive LED obviously won't do anything yet with no hard drive connected up. This one here is just there for a bit of load for the PSU, but we'll hook this up anyway. This thing has options on it here. There's a switch there to select either a momentary power switch or a latching switch. It's currently set to momentary switch. So that will go in there. And the LEDs get hooked up here. We need some RAM. Now I'm just going to fit the chip RAM module just for now. But I do have a full suite of RAM sticks here for this machine. I need to say thank you to Screamo for sending these over to me, just for the cost of postage only. Very kind of them to provide these. So chip RAM module will go in there. Now these are all 4 meg modules that I have. Obviously just 2 meg of chip RAM. So just 2 meg of this SIM will be used. The other 2 will be ignored. And I think that's it. Is it? Nope. I need to hook up the ATX power supply. There's 2 positions on this card for it. You can use either. I'm just using this one because it's handy. RGB's hooked up, sound is hooked up, although we'll not get any sound. Not that I'm expecting this to do anything. But we'll not get sound because there's various components here still missing. Most of the electrolytics are still missing from the board, but the power rails coming out of the modern ATX PSU should be clean enough to allow this thing to start, or hopefully allow it to do something. So power supply on at the wall, and let's see what happens. I would honestly be happy with just a sync signal, given the amount of rework that we've done here. I just want to see this do something on the screen. Anything. We've got sync. I don't quite believe it, but those colors on the screen there, I think that means the BFG is booting. Power LED is up. Oh my god, it's oh, shit. Sorry about that. Yeah, it's working. Definitely didn't expect that. I am a little speechless, to say the least. Yeah. Gonna strip it down again. We'll fit the remaining caps. Then I think we should hook up a floppy drive and see if it'll boot something. I cannot believe it started. Right, let's get all these remaining capacitors on, then we can give it a full test. That's all the new caps fitted. Everything is back together, ready to test, but this time we've also got a floppy drive. Still can't believe this just works. Let's try Amiga test kit. Yep, it's reading that. And memory. 1 megabyte of chip. 128 meg of fast, that's on the BFG. But why have we only got 1 meg of chip? We should have 2. That's a 4 meg sim. Only 2 of it will be used. So where's the other 1? So it seems I might have made a little mistake. I just picked the first sim that came to me, stuck that in there, and yeah, it works. But because this is single-sided, we will only get 1 meg. We're supposed to be using this one, which is a double-sided sim, and with this we're meant to get 2 meg. But if I put this one in, well, as you can see, it tries to start and then it green screens. It just resets and continues looping like that. So I thought we might have had a fault here. This might have been a problem, but no. I think it's actually just the 4000 doesn't like this particular sim. Apparently it is very fussy with what sim it uses as chip RAM. Doesn't like this one, but I found this one in my stash. Another double-sided sim. I'm not actually sure how big this is. I would say it's definitely well more than 2 megabytes. This one might actually be a 16 meg sim, I'm not sure. But with that in there, within Amiga test kit, there's our 2 meg of chip. Now supposedly the other option that we had there, if I didn't have any double-sided sims, we could have used the single-sided. And then these 2 jumpers, we would need to move these both to their 8 megabyte position. Supposedly intended for a different chipset that was never released and was meant to give you 8 megabytes of chip RAM. The Amiga definitely supports no more than 2, but with those jumpers moved, it changes the addressing here of the RAM and allows a single-sided sim to give you 2 megabytes. Just like that. I though am just going to use my double-sided in here, so I do need to put them back to the 2 meg setting. But because we've got these other 4 meg modules, let's just kit this out, will we? And within Amiga test kit now, memory 132 meg of fast total. If we go into this one, list and test memory regions, hey, we've got 2 meg of chip but only 4 meg of fast. It's all a learning curve. I need to change that jumper. It's currently set to 256K by 32. I need to change it to 1 meg by 32. And I believe that will give us the full 16 meg of fast RAM now. Amiga test kit, memory, yeah, 144 total fast. List and test, there it is, 16 meg now of total fast RAM. So how about we just run a quick test on this. We'll test the chip RAM first. Right, it's on its 5th pass there. I'm happy enough to call that good for now. Let's also just check this fast RAM, 16 meg, which is the maximum amount of fast RAM we can have at this position. You could fill that with 8 megabyte sticks, so in theory 32, but you're only ever going to get 16. Right, it's only done 1 pass there, and it did successfully pass that, but it's taking forever. So I'll just leave it for now, we'll call it good. I will do a more thorough test of all this later. Don't see the point in testing the RAM on the BFG. I'm pretty sure that's all good. Now we can't do a keyboard test because I don't have a keyboard for an A4000. So I'll have to get some sort of converter so that I can use, say, a PS2 keyboard, or maybe I could be able to use my A2000 keyboard. But for now, we are keyboardless. Floppy drive, we'll just give it a quick read test. I suspect it's all okay. This floppy drive itself is good. There is a couple of read errors on that disk, so I'm sure we will probably see a few issues here, but you know, seems to be working. And yeah, that's all fine. Those 2 errors there, that's just the read errors that are on that actual disk. Controller ports, well, our mouse obviously works okay. Let's just try the joystick port. Yeah, that's all working. That's all fine. Audio. So yeah, that's not working, but that seems very similar to a fault we had on an A600 recently. I suspect that will be a broken trace around here, close to that op amp. Low pass filter works. So yeah, we will need to take a closer look around this area. I'll just need to buzz things out to see if we can find what is broken. Could be a failed op amp, but I would say it's more likely just to be a cracked trace somewhere. Video all looks pretty good, and yeah, that's fine. CIA, that's all good. Real-time clock, I have fitted the original chip that came out of this board, fitted that there. And yeah, that seems to be working fine. Serial and parallel, we can test that using our little dongles. LEDs have come on the 2 test dongles just to confirm that our voltages are all correct. Let's do the serial test. That's good. And the parallel test. That's good. So just one minor issue to fix then, and that is around this audio section. Got the audio fixed. Turned out to be really simple in the end. Wasn't the problem around this op amp. 4000 must be slightly different from the other machines I've worked on in the past, in that it's actually got 2 op amps. That one and the smaller one here, an LM833. Problem was associated with that one. Wasn't a broken trace though, it was a bad resistor on the bottom side. R304C, it was lying open, and yeah, that was causing the left channel audio levels to get blown away out. Replaced it with a new one, and as you can hear, everything is now fine. Well, that was a bit more work than I initially thought. It took just over 4 weeks in the end to get this board repaired. But I do now have my own Amiga 4000. Yeah, that's something I thought I would never say. I genuinely thought I'd never own one of these machines. Now granted, it is missing a few bits. Need to get it a case. Needs to get its own drives. The floppy drive I was using there is out of my 1200. Need to get a PSU for it. The supply I was using is out of one of my other retro machines. And I suppose we need to make the decision whether we stick with this board or whether we move everything over to the other new board that Kavanos very kindly supplied. Yeah, this does work, but given the amount of patchwork that we did here, it'll always be a weak spot. So I think ultimately in the long term, that's what we will do. We will move the customs and ICs over to that other board. I would just replace all the passives. But that in itself is another massive project. So for now, we'll just move forward with this one, because the next thing I want to try and do is repair this CPU card. In terms of the repair itself, let's just address the elephant in the room, shall we? And the Dremel. I'm sure some people will think that I caused a lot of that damage here using said Dremel to clean off the solder mask. Can't say with any certainty whether I did or whether I didn't, but the patch wires that we needed to fit there are more prevalent towards the battery. The more you work away from that battery, there was less patchwork required, but that whole area was Dremeled. So, you know, if the Dremel damaged it here, why didn't it damage it over here? I just think it was a case that this board was rotten. And yeah, I'm sure you noticed it, but in the process of reflowing things and fitting these caps up here, I managed to melt the back of one of the audio ports and the back of the RGB port. Just touched them with the iron. I have cleaned it up a bit there just using the knife. But yeah, more haste, less speed in terms of that. It is very tight working in this area, but that's no excuse. At least this is my board. And if I was to move all this over to the new PCB, these ports are kind of crusty looking, so I would just replace them all anyway. But that's going to be it for now. So thank you very much for watching. Longer video, just because of the amount of work that we had to do here. But if you did stick with it, I really appreciate that. So thank you very much. I hope you did enjoy the video. Please let me know your thoughts down in the comments, and I'll see you next time.